Ladies and gentlemen, welcome back to Ethan's Code Guild. Today we're going to give a day one update on my to-do list and what we have done so far. If you're new to the channel, then I'd really appreciate if you could like, subscribe, let me know down in the comments below what your thoughts are about the video, what your tips would be if you were developing this project, and just share ideas throughout the video. If you think there's something I could do better or improve on, this is an open community. I really want to try to build something where everyone can give their own ideas, share what they think of projects and share maybe their experience, especially the more seasoned developers out there. It will help me learn, and I'm sure it will also help other people learn, so by all means it would be really appreciated. So how I thought we'd structure this. So first of all, what I'm going to do is just go brief through what I've actually decided to build, and then once we've kind of covered that basis, I'll then just go through what we've done so far, what I've done and how I've done it, and then we'll follow up with what we're going to do next, and then just a mop-up of anything at the end. And by all means, I will always answer questions down in the comments below, so feel free to leave a comment and I will answer it. So we've done a to-do list. Now, why have we done a to-do list? So I'm, fairly new developer, I'd say, and I'm trying to get a better understanding of CRUD techniques, database connections, all of that kind of stuff. And the best way to do that is practice and research. I think most people will know that when it comes to code, it's just about sheer iron will, essentially. So with that being the case, guys, what we've done is we've done this to-do list to practice that. So far I've only been able to do the database and also get the controllers and services set up to get access to the database, so I know everything on that side of things work. Now, how I've done that is I've used multiple different tools. So the framework I'm using is Micronaut Launch. If you don't know where you can find that, I'll attach a link in the video in the description below so you can have a look. We're also using Gradle. That's my preferred build tool. It's one I've got experience with. I haven't necessarily used some of the others, for example Kotlin. I haven't used that yet, and I know there's others out there, so by all means, if you know one that's a bit better or one that might offer better functionality, let me know. The IDE I'm using today is IntelliJ. If you don't know what IDE is, it's Integrated Development Environment. I'm using IntelliJ today. Recently I've used it a lot more. I have found that I got the ultimate version mainly because, for me, doing the front-end stuff, the back-end stuff, and then also the JavaScript stuff, I find easier just to do on one IDE. I'm not a major fan of like sprinting between different ones. I will if I have to, but I just prefer to have one IDE with multiple windows, just for practice and proficiency. As well as that, we're also, at the minute, using a variety of different libraries, which we'll certainly go for as well. Hibernate, JPA, Java Persistence, and we're also using Oracle. Now, we're using Oracle through Docker image. If you don't know what Docker is, Docker essentially allows you to run images, which are bits of code, maybe a project or a service, and it will package all of the configuration files, all of that stuff in it, and then when it's run as what's called a container in that state. And that just means you know it will work from one developer's machine to the other because all of the configuration stuff is already set up. Now, why have I done that for the database? Because it's easily transferable. That's the easy answer for it. You wouldn't necessarily just have to use this database for one particular project. You might want to alter it and use it across a variety of other different projects, and it just makes it a lot easier to change configuration once without having to get multiple people to change it on that machine. With that being the case, what I think we'll go through first is what the database looks like and how I've actually built it. So I'm going to do that by actually showing you my code. Now, what you'll find we will do is show you some of the tips and tricks that I've done personally with the IntelliJ, because I find it a good little hand, essentially. And for me at least, it has helped me, and I have definitely enjoyed using it. So, there we go. So this is my Docker database project, to-do list project is what I've called it. With this being the case, how does it work? So when it comes to Oracle experience, it uses the Docker Compose file, the Docker file, to essentially get that image. Now, that image was already done by someone. I haven't necessarily created the Oracle database from scratch. Why haven't I done that? Because that would involve quite a lot more work, which I just didn't want to practice right now. If you have done it in the past and you got some really good resources though on setting up a database literally from scratch, then by all means please do let me know, because I would love to hear them. It'd be really cool to learn how you've done it as well. It'd be a really good experience, and I'm sure other people watching the video and down in the comments would probably appreciate it as well. So what it does is it gets that image, okay, and then it uses what we call init scripts, okay, to essentially build the schema. Now, what is a schema? A schema with a database is just what's used or described as a blueprint. So it's a blueprint for the users you're going to have, for the tables you're going to have, for any kind of rules or restrictions, all of that kind of stuff. It justifies the blueprint for that particular database. Now, what have I got in my initial scripts? Now, I started this off quite basic. You might want to change this. I will say I will have as well the link to my GitHub repo down below. So if you wanted to potentially borrow this for yourselves and you wanted to experiment with it, by all means, you're more than welcome to. How it works is it uses these initial scripts to build that schema. If you go on to the first one, it's to create a user. Now, why is that important? Well, you're creating the user because you need to know who's using that database, and the easiest way to do that is to have a user who gets specific privileges. Okay, now those specific privileges you can adjust any way you want. It's using the SQL language, but for me, I've used a user called Ethan, which you'll be able to see just here, and you'll see I've got the password as Ethan9901. All right, now you'll see as well that we've got this grant create session here and create table to Ethan. What that essentially means is it grants my user the ability to create tables, to adjust tables, whatever I'd like to do. It also gives me unlimited table space. Now, why is that important? So you might find over one specific table, there could be a large amount of databases in one company or in one server, okay? As we know, we live in a world where everything has databases now, so I wouldn't be surprised. This is just a way to help make sure that you're not going past or beyond the computer's resources. What you got to consider is you might not have just one of these things running. You might have, a few hundred or so forth. And if they're all running on a computer, they need to make sure that they don't overexpand on what the computer can do or what the server can do. Otherwise, you can end up with lost data. You can end up with really, really slow performance, and it's just not a good user experience. And that's what that does. With that being the case as well, what you'll find we're using for the container is that free PDB1. Now you'll find that when you go onto the image documentation, the one I'm using, that's just the default service that particular image uses. If you want access to a database, free PDB1. There are others that you can use for different containers. This is the tables section. Now this bit is where I actually create my tables. All right, so you got here a variety of different things. You've got the schema. Now why have I done that? Because you need to know what schema it's attached to. That's me. You've also got, once again, that container equals free PDB1. This is to make sure that when this is running, it knows that we're on the free PDB1 service in that particular container. For the tasks, it has a task ID, okay, generated by default, and it's the primary key. What that means is, because it's a primary key, with each entry, that's just generated as a default. It's not one you generate yourself, okay? That's what's generated when you put it in. The next one is task name. That can't be null, but that has a maximum amount of characters of 255. Same as task type, also can't be null. That has a maximum of characters of 255. Got task level, that's a number, that's not null either. Then you've got task description as well. Now that one's same thing, 255 characters. Now, once it's got that, I also found you can do different things with tables. So in that particular section, we've created the tables. But what if you want to alter a table? Or you want to alter something in particular? Well, you can do that using the alter table. And how that one will work is you enter alter table, you enter then the table that you want to alter, and then underneath, using indentation, you can then just edit what you like. So for me, I've only experimented with this recently. I've added what's called constraints. Now, I'm relatively new to SQL, so this was new for me, but essentially it allows you to put safeguards in place to stop certain data types or certain bits of data from being put into the database in the wrong way, because it's a lot easier to sort this out now than it is to try to sort it out once the database is actually built. Sorry, once the data has actually gone through to the database. The next one is a seed. Now this one, what it essentially does is it just inserts some values for me. You wouldn't need to have this per se if you didn't want to. So if you're just using a blank database and blank table, and you don't want any data in there as loaded in by default, you wouldn't have to use this file. The reason I chose to add it in by default is because you'll find that it allows me to kind of test the database. So I've got 3 default tasks there, each with different attributes, and they all match the requirements for what needs to be in the attributes and for filling out all the attributes. And then once it's inserted that into the task list, it will then commit, which means that it will then save it to that database. Without the commit, it's not necessarily going to save it to the database, which is a bit of a problem. So it's wise to add that. With that being the case, the next bit is the Docker Compose. Now, how that one works, I'm about to get my head around this. The Docker Compose determines how the service is run. The Docker file determines the image that you're using. So for myself, for the Docker Compose, I've binded it to the port 1521. Okay, but you could change that and bind it to whatever port you wanted. You've also got the environment. Okay, now that one is a mid-level key, something like that. But all that essentially is used for is to determine this, the Oracle password. Now that's important because you need the Oracle password to actually connect to the database. You will find when you go to look up the Docker images, it does give you quite clear guidance on what you do and don't need to do, all right? And you can find that information simply just by researching. That's it, the Docker Compose. Now, how does it actually build it? So what you would do with that one is you use Docker Compose and build. It might just be one actually. 1 second. It might just be build. There we go. Docker build. Docker Compose build. And the reason why you do that is because you want it to build the project that you're building. And then once you have done that, the next stage, okay, is just to get it to actually run. And how do you do that? Well, you can do Docker Compose up. There we go. So what that does is when you do Docker Compose up, is that will then start to run what you've built. Now, a couple of things to highlight. You can run that all in one command. You can do that by using, and I won't actually enter it, but you can use that by using, I'll just type it up here. Use Docker Compose up, there, and then build. All right, that's a way of doing it. Okay, and that'll run all of it in one kind of go, so you don't have to worry. So when you look in the terminal, you'll find that we get this database is ready to use. Now, once again, when you look at the image, you'll find that that's what you need to have, so you know it's running, okay? And you'll also find when you look at it, there's a log of what we've actually done. So we've got all 3 rows that we created earlier. That was in our seed SQL. We've also got the table created just there, okay? And we've also got the user created just up here, all right? Now, this is really good for troubleshooting. If you're not sure and you wanted to kind of check what's gone wrong or what's happened, then what I have found is having a look at this first can sometimes really help, and just looking at the SQL state, the SQL logs, and seeing if any of them differ from what you should be expecting. So that's how I've kind of went for it. By all means, if you're a seasoned developer out there and you're quite common with using Docker, then please do let us know. Everything helps. It helps me out to learn and also would help other people. That's what it does, that one. Alright. So when we've done that, what you'll need to do then is go on Docker to make sure it's running. Now, when I show this to you, let's see what's happened. There we go. You'll see on my screen just now that we've now got the Docker. Now for the Docker, you can see we've got exactly what we saw in the log, okay, in IntelliJ. You can see it started up, you can see the user's been created, table's been created, rows been created, okay, and its database is ready to use. Now, one really cool feature that I found with IntelliJ, which I didn't necessarily know about until quite recently, is when you get IntelliJ Ultimate, you can actually get the database connection set up within your IDE. Now, you're probably asking, why would I want to do that? Well, like with most databases when they run on SQL, you need to interact with them. And you interact with them typically through SQL. Now, that helps because what it means you could do is if you weren't sure whether it's working or you weren't sure whether a certain SQL statement was correct, you can run it as a data in the IntelliJ window and then actually see whether it returns what you're expecting. We're going to give it a go now, and I'm just going to show you how I set that up. So first of all, you go on this little section there, that's a symbol for database. Go on data source, okay. You would then select the data source you're using. In my case, I'm using Oracle, but there's a lot here. I haven't heard of most of these, by the way, so if you are fairly experienced, let me know what ones are particularly good. I know you've got MongoDB as well. So this is where you need to configure your database. Now, for myself, I know that it's not that we're using a service name, okay? So that's what the image is running. Now you swap the service name, whatever it is, in my case, free PDB1. And then once you've done that, you will then go through and you can choose authentication. Now for my particular circumstance, okay, we have got a user and password, okay? You might not have that, by all means, you might have something else instead, but feel free to let me know. Now you're probably wondering, where do we find that username and password? Well, that's in the same place as when you created the user. So you'll find it's Ethan, and you'll find for me as well, it's Ethan9901. Hopefully, and then we'll see in a minute. And then to make sure it's working, what you can do is you can test connection. Now it's always best practice to do this just so you can tell it's working first. So we'll give it a go. Boom, and then we can see it succeeded. So that means it's like the username and password, okay, and it's let me go through as that user for that database. All right. So when we've done that, we can press OK. And then when we click OK, what you'll find it does is it will bring it up in this window here, and it will stay there, okay, for that particular project. So for myself, when it does load, I believe it will eventually. There we go. You'll see we got a variety of different things here in a variety of different folders. Now earlier I mentioned to you about the use of schemas and how they are used to give you the blueprint for the database, give you the users, the tables, all that stuff. Oracle has a bunch of this already set up by default. When we go on users, you can see we've got 33 users, okay? So 33. Now you'll find I'm on there, but you'll find you've got other things as well, okay? So for example, you got system, okay? Which is a higher level one, we get more privileges. You got sys, all right? You got admin as well, I believe you should have on there. No, you don't. But I think sometimes you have sysadmin as one. But for me, you can see I'm there as a user. Table spaces, you can see it will give kind of spaces that are just on there for everyone. For me, it's my user just here. It's my tables, that's what I've got. It's my task list, which is a table we created. And then when you click on that, you'll find it gives you the options. So it gives you the columns, gives you the keys, gives you the indexes, and it gives you the checks. Okay. Now that checks as a reflection of the constraints that we added earlier. The columns give you the columns that you're using. Now that is really, really useful. You're probably wondering, well, why is that useful? Why do I need it there? Why can't I just get it on another kind of project or something like that? Well, when you're designing your project, dependent on what library you're using to interact with it, sometimes having those column names quick to hand can be easier to make sure you got, quite frankly, the right spelling. So I'll show you that in a bit on my backend stuff, but that is why I use it. The other reason is when you do go on this, you get the option, okay, where it says up here, jump to query console. Now, what that means is it's already loaded it, but what that means is you're able to use the query console we've got here to run SQL commands. So I could say, for example, select all from task list. Should we finish it off? And then I can run that query, and then as you can see just underneath here, I get all 3 tasks. Okay. You might want to do something else. So select go task ID is 1. Let's go with 1, shall we? task ID as 1. So then when we run it, there we go, and it'll bring back that task with number 1. Now that's really useful if you're doing particularly complex queries. We're not doing very complex ones. I just thought I'd give you a quick example of how you can connect your own database, all right? And how you can use that in IntelliJ to, instead of having to go to, for example, SQL Developer, just do it directly in the console. And for me, having that with AI features, even though it's only £22, is very well worth it, because it just saves you time, especially the more you do the project and it starts to pick up on what your goals actually are. So that's the database side. That's all I've done for that so far. Okay. Now for the project, I am planning on doing like a game function. So when you tick off tasks, you get, for example, a point or a set of points. How we're going to do that for the database and what future expansions we're going to add is we'll need another table, which I'll probably just call point list or point table. And then you can use joins. Now joins are a way of connecting using relational databases to be able to connect one thing to the other. So the ID, for the ID, for example, or for the task level might be linked to the points you get. So what might we do for that one? So we might go with the task level and use the task level that's put in the task list is the factor for the task points that you get for completing that task. It doesn't really make too much sense, but it'll make sense in the next video when we go through day 2. I'm still thinking about that bit for now. The next bit is the backend. Oh, if you're wondering, yes, I do play these games. I know I'm very, very boring. Doom Eternal, if you haven't played it, booming game, absolutely booming. So this is the backend. Now for this one, we've got a variety of different things. Okay, this is quite built up from scratch. This is using that Micronaut, okay, to actually build the project. We've done that for different reasons, sets up the dependencies and the file structure a little bit easier for me. And you'll also find it allows me to also have the kind of test side of things ready and to hand. All right, and they do quite good annotations in terms of allowing you to test for the controllers and all of that. When we have a look, what you'll find is if you go from the start, we have a variety of different controllers, models, and services. Now controllers, I think of them like traffic wardens, so they take you, or take the data, shall I say, from one place and they direct it to the next where it gets processed and they help navigate it back home. That's what the controller does. We've got 3. We've got a game points controller, not anything in it yet. We've got a home controller, okay, which I'm going to do as a login. And we've also got a task management controller. Now this is the one that actually begins task creation and all the CRUD functions. All right. Following on from that, we've got what's called a model. Now models are really important. What models allow you to do is essentially build I think of it like a package of data with particular attributes that can be used as arguments, can be used for when you send data back, and what it allows you to do is expand your code a lot easier. So what you'll find, and you'll see this in a minute, when you're using arguments, some people might use the arguments with raw data, so just calling it a long or using a string or using a double or a boolean, whatever it might be, and they will use that as the argument. When you're dealing with more complex things, particularly with object-oriented programming, you're dealing with objects that is easier to move around when you have attributes. And that's what this does. It helps you move things around with the attributes in one go. I'll give you a bit of that example of how that works. So using our adapter service, which I put just here, we might want to create a task. Now, in order to create that task, it takes the argument of task object model, which is what we saw. So then when it comes across, we might want to change, say, the task name into another thing, or we might want to add an attribute. Instead of me having to rewrite the argument, all I have to rewrite is the model from this side and the model from the other side. And it's a lot easier to expand and makes it a lot easier and more tidy. Obviously, you might consider you might be dealing with hundreds of controllers and hundreds of models, but if you can make your life easier by having to worry about less when you expand it, that's what's easier. Okay, and that goes with the solid principle: open for expansion and open for extension. Closed to expansion, I think it is. Yeah, that's it, yeah. Open for, yeah, sorry guys, I had a real brain moment then. Yeah, open for extension, close for modification. So that's quite important to make sure that you can extend things, but you're not having to modify things where you can. All right. So for the adapter service, if we go on to this, I'll show you how that one works. Now, my adapter service that's just there, okay, is what I've built so far. You'll find I've got the add task service and task retrieval service. I've not necessarily done anything with that yet. Why haven't I done anything with that? Because as it currently stands, I'm only in the very beginning stages. The adapter service that we're testing at the minute to make sure everything works, I've separated into CRUD functions. Now we've got a variety of different dependencies here, which I will go through, but what dependencies essentially allow you to do is pull libraries of code from elsewhere to help fulfill either a service or a requirement or a task or whatever you're trying to achieve. For myself, I've got two. I've got what's called a Mapstruct task mapper, and I've got also an entity manager. Okay. Now the entity manager, what that essentially allows me to do is control the entities in my database, and also the task mapper allows me to move the data from being an entity, which is how the database sees it, to a data object that can be manipulated in here. For a bit more context, we'll start off with the entity manager. Now the entity manager is something that uses Hibernate and also JPA, and it allows you to make use of that library to essentially put in your own SQL statements, or allows you to avoid putting SQL statements in altogether by using pre-configured ones that are already in the library to do certain tasks. So for the first one, for create tasks, this is a brilliant example. You can see we wanted to create a task, we got the task object model, okay, and then for the entity manager we use the persist, which essentially means it adds whatever the argument is onto the database, and in this instance we're mapping the task to an entity and then adding that task object to the database. We've not wrote any SQL in there, entity manager does it for us. If we did it ourselves, which we can, then that's just a lot more time, essentially. The next bit, which you can do, is the task mapper side. Now I've done this using Mapstruct. Now Mapstruct, if you're unaware of what it is, it essentially allows you to move object types from one to the other. Now why are we having to move it from an entity to a database object, sorry, data object? What's the difference? Well, the difference is when we get and call or interact with the database, the entity manager needs to know what the table looks like and what the columns are, because otherwise it can't match the values to anything. So how does it do this? So when you load up your database, so when the database is loaded up and when this program is ran, it finds the package, this one here, the JPA, and it scans this entity. Now it scans this entity so Entity Manager knows when it comes across that particular table, this is what the columns represent. So you can see we got the task ID as a column, which is ID, we got task name, which is task name, task type, task level, task description, and we've got getters and setters there, okay? So we just get and set information as and when we need to, but also as and when the entity manager needs to. When it calls that data, it will use the gets and sets to be able to set the data in place for the object. The problem is when we start to then move that into our backend, it might not want to manipulate it in that way, and you might find you want your own methods, or you might have your own kind of extra bits of data that you might want to create as a result of the entity. So the task mapper simply maps what attributes match and what attributes are the same. Now this is really important. You have got to make sure that the actual attributes that you're putting in, okay, for the entity, which is these lines here where it says task name and the camel pacing, match the actual object. and the model that you're using, which is here. If they don't match, it won't map properly. Now, you can tell that usually because when you're trying to map it, if you've got most of it right and you've done a spelling mistake, that particular attribute won't be there and it'll be missing. And one of the first things I suggest doing is looking at it, because if you're like me, it's usually the reason why it's gone essentially terribly wrong. With that being the case, once it's happy with the mapper and it's mapped it across and it's done the Entity Manager has done what it wants to do, then you can move on to doing the more advanced stuff once you've set it all up. So in my case, we've got what we call the create task function, fetch all task models, retrieve a specific task, update task, and then delete task. I'm going to go through these really quickly so you can see, but they're quite self-explicit. Fetch all tasks creates an array list, and then it uses what we call a typed query. Now, the difference between a typed query and just a normal query, typed query, you dictate what you know it's going to bring back. All right. So in my instance, I'm creating a new typed query, using the Entity Manager to create that query, and I'm saying select X, or my entity, from my task entity, which is the class, T. All right. And that's saying task entity.class. That lets it know what the thing is that you're actually putting in the argument. All right. Once it's done that, it uses the query to get result list, and it gets the results, and it puts that in the list for me. And then all it simply does next is map each task entity in the list to a model, and then adds it to the task models array list, and then returns that. So you can use it to see all the tasks. Now, why is that important? So for it, it's important because if we don't do that and we don't map it across, as I said, it's not really going to be clear. And I've done it this way because it's an advanced loop, it's easy to just manipulate. The next one is retrieve the task by ID. So it takes an ID in the form of a long, and then it just uses the find function to find a particular task entity and looks for one with that ID. And that's how it does that. And then it returns it and maps it to a model. Okay. The next stage, which is the update task, that uses the ID, the field that you're updating, the replacement value. Now, what's wrong with this? Well, what's wrong with this is I've not actually done this in a model yet, which is something I still need to do. So that's not very safe. So we will fix that in the future, but something to keep in mind. How it works though, is it will use a task entity and it will go find task entity with the ID. And then once it finds it, it will then go through a bit of safety checks. So if the entity is null, then it doesn't exist, you can't find it. If the field to update is null, then the field can't be blank because you can't update it with no particular field. If the replacement value is also null, then once again, you can't replace it. And then what it does is it will go through what the thing that they want to update is using a switch case statement. And then if the field to update string matches one of these cases, then that is the aspect that it will update. So we've got task name, type, level, and description. If one of those match the field the user's updating, it'll then set the new task type as, or the new thing as the replacement value. Last one is delete task. So how does that work? So it gets an ID once again, it goes through the Entity Manager to find a task with that particular ID, and then once it's got it, it will then simply check to see if it's null, just to make sure. Once again, safety checks are good, and then it will remove that entity from the database, from the table. Alright. That's it with that one. That's all we've done so far. What I thought I would do is a quick demonstration on how that actually works, so you can see it yourselves. 1 second. I'm just going to quickly set that up. Now, how I'm going to do this demonstration, just for those of you who might not necessarily have seen this, I imagine most of you probably have, but it's still worth showing you. I will show you what I have got on my Postman. Now, why am I using Postman? It's really good for checking APIs, okay? So it essentially allows you to do quick kind of dummy tests, so to speak. So you can mock if a certain controller was called with a certain argument, what the response would be. So for my case, I'm just going to quickly run this. That's what I need to do first. 1 second. FYI, it is getting there, it just takes a little bit of time. In the meantime, what we will do So how the controller works is you need to copy the bit that you've got inside of the terminal, which in my case is where it's running, which is this local port. And then we want to get the controller name, which is that one there. And then we want to get the next bit, which is what we want. In my case, you can already see it's already filled out, so it's get tasks. And then what you do is once you click get tasks, it will return what it needs. So in my case, it will return all 3 tasks. So you can see we've got there each task. It's in the form of JSON, okay, and you've got all the information for it. You will also find one thing that might help those of you out there. I've used also what we call loggers. Now, I didn't really understand what loggers were at the start, but it's something that you can set up, okay, in an XML file. What the logger allows you to do is select a particular thing. In my case, it's Hibernate, because that's what my database is using, okay? You can also use it for different things, but what it will do is you can select what you want it to log and the level in which you want it to log it. So for myself, you can see we've got trace, we've got debug as well I've used, and we also got info. Now, why might you want to do that? Well, if you can't necessarily get enough information from the console when it breaks straight away, you can use the loggers to get specific information, try to get more specific information. From what I've experienced with the coding side, most of the problems I've had don't necessarily seem to be fixing the problem, it's actually understanding the problem you're fixing. And that has been a really useful tool that I've really tried to take advantage of to help me understand what's going wrong. And that, ladies and gentlemen, so far is what we've got in my project. So with that being the case, I do hope you enjoyed. I will just leave, as I said, a link onto my project that you will see on my GitHub. So please have a look. It's Oswald, by the way. It's not the channel name, but I've always used Oswald. I hope you enjoyed the video. I appreciate all of you who watch, like, subscribe, and love the channel. And by all means, as I said, let me know down in the comments if you've got any suggestions or if you think I could do anything better. I'm here to learn, everyone wants to learn, and hopefully we can learn together as a guild. So with that being the case, guys, I will see you all soon. Have a really, really good rest of your day. Take care, guys.